Hi everyone, so welcome back to my session. This is going to be control system, right? Though this subject is considered to be one of the easiest subject, but sometimes what happens in the gate examination, you are not able to solve question within time. So you might skip question, or sometimes what happens, the question also might come. You might not be familiar with that concept, so you might not be able to solve the question, right? So what I'm going to do in this case, in this subject, is I will be giving you the recap, okay, and how quickly you can solve any question, right? I will be giving you some kind of a smart technique, you can say. We will not say that is a shortcut, but you have to understand. So I will be starting from the last chapter, okay, last chapter, that is state space analysis, and I will give you the entire picture what you should study and how to solve question based on state space analysis, because 2 mark question is expected in each branch, okay, understand. So let's move ahead and start the session. Okay, in this session what I will be talking here is the state space analysis, okay. See, strictly you have to follow one book which is Nice, okay. Nice is one of the very good book for this, okay. So state space analysis, in state space analysis, or we sometimes call it SSA, right? What we call SSA. So this is the last chapter of control system, and you can expect 2 mark question from this, right? So here the state, here we have got state space analysis, right? So what is the prerequisite to understand this chapter is you need to be good at matrices, right? Okay. तो आपका मैट्रिक्स अच्छा होना चाहिए. Okay, all concept of matrices. I mean, the way I teach matrix, okay, you should be good in that level. Okay, state space analysis में क्या होगा कि you need to be good at matrices. That's it. Okay, and dealing with the Laplace transform, having knowledge about signal flow graph, all those things, right? Fine. So so in this case, in the state space analysis, okay, what are the topic, what are the concept that they can ask, right? That is very important. So first of all, you should know the standard form of state model. Okay, the very first important information that you have to keep in mind is what is the standard form of any state model, you can say state model. स्टैंडर्ड फॉर्म ऑफ स्टेट मॉडल, आपको ये चीज याद रखना है. व्हाट इज द स्टैंडर्ड फॉर्म ऑफ स्टेट मॉडल? as I am revising this subject, so I'm not teaching in very great detail what is the state, okay, and so on and so forth. I'm going to highlight important expressions, okay. The standard form of state model is nothing but what you have to keep in mind, that is x dot, okay, ax plus bu, and then y is going to go to cx plus du, right? Okay, I hope this makes sense. So this is also known as state equation. We call it state equation, or sometimes we call it dynamic equation as well. Dynamic equation, right? So what is this, guys? This is nothing but derivative of x. Okay, derivative of x. X is the first derivative. You can say x dot means derivative of x equal to ax plus bu, right? And this is a by, okay, by equal to what? Cx plus du, right? So if you have attended my class on matrices, so you will treat this by as a by vector, okay. You can say this is nothing but output vector, okay. So we'll say that by is nothing but output vector, okay, and c is going to be a state vector, right? Or sorry, this x is going to be a state vector, you can say, right? X, okay. And this is nothing but differentiation of state vector, right? Differentiation of state vector, right? What is this x? X is nothing but state vector, okay. Please remember these things, okay. What you are doing is a is going to be a matrix. You're multiplying a with the vector x, okay. So ax plus bu, okay, ax plus bu, okay, bu and c and d. So there are 4, you see, a b c d, right? There are 4 matrices which you will get, okay, of different order, right? So there are four matrices A, B, C, D, okay, in this state standard form of state model, right? Please remember. And first one is the differentiation of state vector, and by is going to be output vector, okay, output vector, okay, and this is nothing but output equation, you can say output equation. So first equation is what? State equation that you have to remember, and this is output equation. So when you will find the output of certain model, so you have to use by equal to Cx plus du, right? This is the equation that we are going to use to evaluate by. ठीक है, ये याद रखना, ये important है, ठीक है? So x is what? X is the state vector, right? State vector. What is this state? State is nothing but a future we have here, right? You know, we'll talk about that, okay? So yes. So I think this is clear. So you can mention here all these things. Let me take this standard form only from here. Okay? I'm just going to copy this standard form, and I will highlight these A, B, C, D matrices. What are they? Do you see, guys, this A, B, C, D? So A is nothing but we call it state matrix. इसको क्या बोलते हैं? State matrix we call it, okay? And B is nothing but input matrix. Okay, input matrix. Okay, A is nothing but state matrix, B is nothing but input matrix. Okay, so you have to suppose signal flow graph is given. Whenever signal flow graph will be given, suppose this is U, right, and this is X, you can say some state vector X. So you have to go from input to state vector like this. Okay, input to state vector like this. Okay, understood. So all these paths we will see in case of state diagram. I mean, whenever the signal flow graph will be given, right? So A is state matrix. आपको याद रखना है. State matrix is multiplied with the state vector. Okay, so that's what I'm saying. If you have good knowledge about matrices, this chapter is for you, right? So A, B, and C is nothing but your output matrix, which is because this is present in the output equation, right? And D is going to be a transmission matrix. Transmission matrix. Okay. Understood. So what you have to keep in mind is the standard form of state model. State, okay. X differentiation of state vector is equal to AX plus BU and by equal to CX plus DU, right? And these matrices are like state matrix, input matrix, output matrix, transmission matrix. Okay, understood. Now the question comes into picture is what will be the order of the matrix? Okay, order of the matrix. What will be the order of A matrix? What is going to be the order of B matrix? What is going to be the order of C matrix and D matrix? Right, that is very important to remember. So I'm going to consider here the multi-input, multi-output system. So you see here, multi-input, multi-output system. So this is nothing but multi-input and multi-output system. Okay, so here we are going to give some input here. So you can say these are the inputs. You can say x1, x2, and so on. Okay, there are n number of components. Sorry, not x1, guys. Okay, we should give input as u, right? So u1, u2. Okay, these are the inputs. So always remember, input is represented with the help of u. Okay, and state vectors are represented with the help of x, x1, x2, right, and so on. There are n number of components. There are n element in the vector, right? x1, x2, dot dot xn. And how many inputs are there? You can say inputs are like um, right? So m inputs are there, right? Okay, m number of inputs are there. Okay, and output you can take it. So output is nothing but there are, you can say p by 1, by 2, and by p. Okay, so this is nothing but output port, right? And this is input port. Okay, so you can say that there are m inputs, there are p outputs, okay, and there are n states, state variables. Fine. So if you know this, you have the idea about how many states are there. If you know how many inputs are there, if you know how many outputs are there, so you can decide the order of this A, B, and C and D matrix. Okay, that is very simple. So let me talk about input vector. Okay, input vector is nothing but you can say a column vector only, U. Okay, which is a column vector. We will write like this: U1, U2, and so on, UM. Now you can decide M into 1 is going to be the order of the matrix U, right? I hope this makes sense to all, right? So keep in mind this. This is very, very important, right? So U is a column matrix, you can say, okay? And आपका, you can take output vector. Output vector, output vector is by. Output vector is by, and by is also like you can say column vector by 1, by 2, and so on, by P, right? It is P cross 1. I hope this makes sense, right? Now state vector, let's talk about state vector. State vector, so state vector is nothing but X. What is the order of this? How many elements are there? There are n elements, right? So आपको याद रखना है x1, x2, and so on, xn. Here n cross 1. Understood? So please keep in mind, this is very important concept, right? So suppose multi-input, multi-output you are considering, there will be input vector, there will be output vector. Okay, you can say you are solving linear algebra problem simply, right? State space analysis में यही करना है, right? So now let me write let me recall the equation here. The input equation, the equation you need to recall, that state equation, you can say. The state equation is X differentiation of state vector equal to AX plus BU, right? So you can decide now the order of the matrix. Okay, so order of the matrix is gonna be, this is having order, you can say U is having order of what? U is having order of input. Input is nothing but there are M in number of inputs. How many inputs are there? M. You can say this is going to be M cross 1, right? And now your B is going to be what? Your B will be, you can say, N cross M, right? Okay? It should match here, right? And suppose X is nothing but what? N into 1. So your A should be N cross N. N cross N, right? Then this should be what? This should be, when you can add two matrices, suppose the overall matrix is going to be N cross N, N cross 1, right? So it should be N cross 1 only, right? I hope this makes sense. Okay. When you can add two matrices, when both matrices have got the same size. Okay, if the size is not same, then you can't add it. So the differentiation of the state vector is going to be the order of differentiation of x dot. What is the size of that? N cross 1. Okay, it matches with the state vector. Okay, please remember. So this is how we decide. Okay, this is how we decide the order of the matrices, all these three matrices. Okay, and order of the differential state vector must be equal to order of the state vector, right? That is very important to observe. Okay, order of the state differential vector is going to be matching with the order of the state vector, right? Now let us talk about the output equation, that is by. तो by क्या है आपका? Cx plus du, right? Cx plus du. The u is nothing but m cross 1, right? And x is nothing but n cross 1, right? So what is this C matrix? So C is going to be what? C is going to be P cross n, right? P cross n, okay? And this D is nothing but P cross m, okay? P cross m. Why P cross? Because there are P number of, so you need what? So you need at by, the size of by should be what? The size of by should be P cross 1, right? That's why we have taken this. Okay, understood? How many outputs are there? Accordingly you can decide number of row is going to present, okay, in case of C matrix, okay, and number of row will be present in the D matrix, right? So please remember how to decide this order, right? How to decide this order. Okay, so first of all we will learn the shortcuts, okay, how to find the state model, okay, how to find the state model, or you can say how to find these matrices A, B, C, D from the differential equation, right? Okay, so some differential equation is given. You can say model number 1 that you can expect in your exam. Model number 1 that you can expect in your exam is what? See, differential equation will be given and you have to write the state model. Writing a state model is nothing but what? Finding different, finding this matrices and all, right? Or writing in the state model, state equations, right? So, state model to given differential equation of, okay, differential equation, right? Understood? So state model to given differential equation. So suppose you have got one differential equation. I'm just going to take one question. You can understand, right? So I'm just going to give you the direct method, okay, how to write directly. Okay, please remember this. This is very important. So state model to given differential equation आपको याद रखना है. तो पहले क्या है? First of all, what you have to keep in mind, what is state model, right? State model, that is x differential vector operator is equal to differential state vector operator vector is equal to ax plus bu, and by equal to what? cx plus du, right? So there are three matrices. तो मान लो आपके पास differential equation given है, okay? So how to write the, how to get the state model of that differential equation, right? So suppose by is given, by, okay, by triple dot, and this is 3 double dot, okay, plus 5 by dot plus 7 by, okay, equal to 10u, right? So this is the differential equation that is given in your question, right? That is given in your question, you can say, okay? Now you have to write the state model. So I will be giving you the smart method, or you can say by inspection. By inspection, how can you write? By inspection, you have to find x dot equal to ax plus bu. Ax plus bu. So what will be this matrix A? What will be this matrix B? And you have to also find y equal to cx plus du. Right? So I will be also writing this A, right? Now, you see here, guys, what is this order? Order of the matrix. What is the order of this differential equation? The order of differential equation is 3. Order of the differential equation is 3. It means number of state is going to be 3, right? If order of the differential equation is 3 means what? There will be 3 state vectors, you can say. Component is going to be 3. So you can say that x1 dot, x2 dot, okay, x3 dot, right? Now you write A matrix. Directly I'm saying by inspection, right? And the it will match with x1, x2, x3, right? The order is going to be same. This is 3 cross 1. This is 3 cross 1, and this is also 3 cross 1. So this should be 3 cross 3, right? Now, and one more matrix will be there, okay? So I will be writing all these things. Just wait and watch. Okay? So from differential equation, how can you write directly? By inspection, I'm telling you. So by inspection means what you have to do here is, please remember, this is important, right? This is very important, okay? So yeah, so what you can do here is you can go like this, okay? Please remember, you can go like this. What is this? Start from 7 by, then take 5 by dash plus 3 by double dash, okay? I mean double dot, right? Okay, so this is going to give you the last row of the A matrix. Last row of the A matrix, okay? So I'm just going to write here. You see what you have to do. You have to take this coefficient of this by first, okay, and take the opposite sign of that, okay? Take the opposite sign of that, okay? What you have to do? With opposite sign, okay, of required coefficient, you can say. Okay. Understood? Please remember, this is very important. So how I have decided that there are and how many vectors are there? So remember, if the order of the matrix or order of the differential equation is 3, then you have to take this. So what you have to do? You have to go like this, okay? You can say from right to left and take 7 and take the opposite sign of that. So you write here -7. Okay, then you can say that -5 and -3. Okay. -5 and -3, right? This will be the last row. You can directly write. And how you have to write this, you remember 0, you put 1 here, then 0, and then 0 0 1 here. Okay, please write like this. Okay, what you have to do is start with 0 1 0, then 0 0 1. Okay, that is done. So you got the A matrix. How you have got this A matrix? The last row only you have to choose. Okay, and this should be if you have put 1 here, right, so you have to put 1 here then, right? So this is the by inspection technique. You can write you can write this you can get this straight transition matrix. Sometimes we call it straight transition matrix as well. In future you will see, right? So this A is going to be a matrix. Okay, remember. Okay, this is called state matrix, right? Okay. How do we get this state matrix? I have told you the concept, right? So please remember. So okay, this is going to be you can say that this is going to be A matrix. Now what is going to be B matrix? You see here there is 10. What is the coefficient of this? There is 10 only, so you can say this is going to be 0 0 10, right? 0 0 10, and you just write u vector. Okay, so this is nothing but B matrix, right? So how to obtain this B matrix? Simply you have to take the coefficient of u. Okay, there is only one u, so you just, there will be one component which is non-zero, right? Okay, perfect. Okay, so this is the direct way of writing, and I hope this makes sense to you. तो आपको एक स्ट्रक्चर याद रखना है. Remember this structure. Okay, what is this structure of A? Structure of A is going to be, please remember, you have to always write 0 1 0 0, then 0 0 1 0 0, like this, 0 0 0 1 0 0, and so on. And last row should be what? Coefficient. Okay, coefficient from last to first. Last to first. Okay, with opposite sign. Okay, so you will not take much time to solve the question, right? You can directly, okay, please remember. Okay, see, there are different forms. I will discuss canonical forms, CCF, OCF, so many forms are there. I will talk about that, but please remember this is one of the standard one. From differential equation you can directly get this format. Okay, 0 1 0 0, 0 0 1, okay, like this. Okay, so if you partition this matrix, okay, if you partition this matrix, guys, so I have talked about partition as well, okay, in some of the class. If you partition this, you will find that this matrix is coming out to be an identity matrix here, right? If you partition this matrix, so this is a kind of identity matrix that you might get. Okay, please remember. Okay. Now how to get by? How to get this by? That is very important. Okay, so understood. Okay, so by can be obtained. By is simple. By is not that tough, right? So you can write directly by as well. So by is going to be, okay, 1 0 0, right? You have to start from first. Okay, you have to write first, okay, as 1, and other will be 0, and then you can write here x1 x2 x3. Okay, this is going to be your by. Okay, it's very simple. You can write directly. Okay, this is going to be by. Okay. Next. Okay, so A matrix, I think everybody can write. Okay, so let me take one example here so that you guys can so I will take one example, but let me talk about different forms here, right? Different state model has different forms, right? So the form which I have got right now is called as CCF. इस form को हम लोग क्या बोलते हैं, याद रखना. This form is basically a CCF, right? Please remember this form. Okay, what we obtain directly from the differential equation is called CCF. Okay, what is the meaning of CCF? Okay, controllable canonical form, right? So the state model are not unique, remember. The state model is not unique. Okay. The state model is not unique. Please keep in mind this, right? In the options, you might get the same, you might not get the same, because there are 4 models that you have to remember, right? The state model is not unique, please remember. Okay. So but there are 4 types of state model that you have to remember. Okay. There are 4 types of state model. There are 4 types of state models. So after attending my lecture, you can refer this niche book. You will be finding very easy then. Okay. So there are 4 state models are there. I think everybody might be familiar also. First is called CCF, right? CCF. Second is called OCF. Okay, controllable canonical form. Controllable canonical form. See, if your concept is clear, guys, you can solve any question. But if I'm solving question only and you are learning from the question only, then there is very remote chance that you will get rank. Okay, so don't learn from the question, learn from the first learn the concept, then apply those concept in the question, right? तो आपको ये पता नहीं होगा 4 टाइप्स के होते हैं फॉर्म्स, राइट? You always make mistake finding the state model from the given differential equation. So now you will not make mistake, right? So there are 4 types of state model. Please remember CCF, OCF, right? And third one is we call it diagonalization. Okay, I think in the matrices many people might have studied about this diagonalization, or we call it normal form. Okay, diagonalization everybody might have studied in matrices. ठीक है. CCF का मतलब क्या होता है? Controllable canonical form. OCF means, please remember these points, right? OCF means what? OCF means observable. Okay, observable canonical form, right? And third is diagonalization form, and diagonalization, or you can say normal form. And fourth one is Jordan canonical form. Jordan canonical form. We call it JCF. Okay, JCF. So CCF is obtained directly. Okay. If you have got CCF, right? How to obtain CCF? जैसा मैंने आपको एक टेक्निक बताई, right? From the last to first, you have to go and take the coefficient, but with opposite sign. That will give you that the last row of the state matrix, state transition matrix, sometimes we call it. You will get the last row of the element of last row of the okay. So in case of CCF, you can directly obtain from the state model, please remember. But how to obtain OCF? So always keep in mind, this is very important. देखो CCF तो आपको पता है, CCF का फॉर्मेट क्या होगा? How does CCF look like? याद रखना, CCF means this 0 1 0 0, okay, 0 0 1 0, right, 0 0 0 1, right, like this. Okay, and last row is gonna be what? Last row is going to be coefficient from first to last with opposite sign. Okay, with opposite sign. Please remember this. Understand? So you will be able to do any question then. So CCF तो आपको पता चल गया. So if you are able to get CCF, so what I will suggest here is, in the options, if CCF is present, you can answer this. But suppose that is a MSQ question, right? So state model is not unique, right? So if it is not unique, means multiple answers are possible, right? 4 options, 4 forms are possible, right? So in the options you have to check all the forms then, right? So if it is MCQ question, fine, right? So how to find OCF from the CCF, right? So I think directly you can get OCF, right? Sorry, CCF, but how to get OCF, that is very important. Okay. So OCF, which is observable, canonical form. Okay, observable canonical form, that is OCF, right? So OCF can be obtained just by taking the transpose of A matrix ka transpose. Just you take the transpose, that's it. Okay. If you take the transpose of A, right, whatever matrix you got from canonical, controllable canonical form, just take the transpose of that guy, right? So you will get the OCF. It is very simple, right? So you can remember, right? So let me show you. Suppose you got this matrix A, right? Suppose you got this matrix A. Okay. This is a matrix that you have got. Fine. So we can copy and paste here. ठीक है, ये मैट्रिक्स आपको मिल गई है, राइट? So let me remove all these guys. Okay, this is a matrix A that you have got, right? Okay, this is nothing but ACCF, right? Controllable canonical form. Now you want to find OCF. What you will do? You will take the, you have to interchange now. So 0 1 0 you put here, 0 0 1, right? -7 -5 -3, like this. Okay, so I think order is gonna be same, but what is this AOCF? AOCF is nothing but the transpose of ACF, CCF. What is the meaning of transpose? Transpose is very simple linear transformation that you have to understand. Okay, transpose is a linear transformation. Okay, transpose is nothing but interchanging rows and columns. That's it. Okay, interchanging rows and columns. Okay, so from this CCF you can get OCF. Please remember this, right? It is very important. Okay? And how to get B? Suppose you have got BCCF, right? So you know that how to write this BCCF, right? BCCF we get directly. Okay, we start from here. You can say B1, B2, B3, and so on. We go to suppose B0. Sorry, I should write like this. So this is CCF, right? What we get directly from the differential equation, CCF. This is nothing but B0, B1, B2, B3. Right? So you have to start from like this. Start writing here 10, then 0, 0, 0. Start and end like this. Okay, start and end like this. Okay. I hope this makes sense. Okay. But in case of B OCF, right? In case of BOCF, what you have to do? You have to reverse it. You have to reverse it. You can say this is nothing but B3, B2, B1, B0, and you start from here. Then start and end like this. So in case of B, that you have to do. And in case of C also, that right? This is CCF. Okay. So CCF means you will start from where to where, that you know. C1, C0, C1, C2, C3. You will start from here and then end like this in this direction, like 1 0 0 0, right? Because there is only one output, right? That is the OCF is going to be what? This is important, right? This is very important. So you can reverse now C3, C2, C1, C0. Now you start from this and go like this. So 0 0 0 1, right? So CCF and OCFs are very simple. If you get CCF, you can get OCF, right? So in the options, you have to check all the concept, right? So I think this is clear. Start from here and here, right? So like you have got C was 1 0 0, right? In case of CCF, so what is OCF here? It will be 0 0 1. Right? Now I'm going to give you one very important, let me solve one question so that you can understand this concept. And try to solve PYQ from all the branch, right? So, okay, so state model from the differential equation कैसे लिखते हैं directly, right? Okay, I'll talk about diagonalization or normal form, or you can say Jordan form, okay, very soon. But please remember this, okay? OCF and LCF, OCF first is CCF directly obtained from the differential equation. तो अब देखो यहाँ पर क्या है, differential equation is given, that is y triple dash plus 2 by double dash plus 4y. So I think there are four, okay, it's a fourth order. So there will be 3 dot, there will be 2 dot, then 6 by dot plus 8 by equal to 5u. Right? So this is the differential equation they have given, right? Differential equation they have given. Now you have to directly write the matrix. Can you find the matrix A? You will say yes, sir. A matrix is going to be of what order? It will be 4 by 4 order, that you can understand always, right? Because the order of the differential equation is 4, so the order of the state transition matrix, or you can see state matrix, is going to be 4 by 4. Now what you have to do, you write here 0 1 0 0 0 0 1 0 0 0 0 1, and last row is going to be start from like this, okay? Start like this, so it is -8 -6, okay, -4 and -2. Okay, I hope this makes sense to you, right? Start -8 from this side to that side, okay? Please remember. So this is a matrix A that you have got directly, right? And the B matrix, you have to start from here, you have to end here, right? So you can say 5 and 0 0 0, right? Okay, and what is this C? C is going to be same, only 1 0 0 0. You got this, okay? So I think this is clear for all, right? So how to obtain this? Now this is ACF that you have got. ACCF, CCF. Okay, we are starting from here and writing like this, and this is also CCF. Now if you want to find OCF, right? If you want to find OCF, then how do we find that? So just take the transpose of that. That's it. Okay, of the A matrix, you will get OCF, right? So please remember that this is first question that you can get, state model, or you can say state finding state transition matrix from the differential equation, right, of any order. So you can get like this, okay? And there is a detailed procedure as well. So let me tell you one detailed procedure as well. Detailed procedure, okay, to obtain state transition matrix. ठीक है, तो देखो क्या है, मान लो आपके पास एक it is given like this, fourth order, 2 by plus 4 by double dash plus 6 by dot plus 8 by equal to 5u. Okay? Now what you can do here, it's a very simple process, right? How? Okay, so step number 1 is what? You have to choose by equal to x1. Okay, first is by equal to x1, you choose, right, directly by equal to what? X1. Okay, first you take by equal to x1. This is the first step that you have to do, right? By equal to x1 you have to take, okay, there x2 x3 is not there, right? So x1 you have taken by equal to x1, right? Now what you can do here is if you differentiate x1 dot, right, so you can consider x1 dash is going to be equal to x2. Okay, sorry, if you differentiate this, right, okay, so you will differentiate y dash also, which is nothing but x2, you can say. Okay, now you take x2 dot. X2 dot means it is nothing but by double dash. Okay, by double dash, okay, I mean double dot, you can say, and by double dot is nothing but what, you can say x3. Right? Now you take x3. Okay, so how many state variable that states you have to consider? There will be x4, right? X3 is nothing but you can say by triple, okay, because you're taking dot of this, so it becomes 3 times differentiation has been done. This is x4. Okay. I hope this makes sense to you, right? Next is the x4 dot, right? So it is nothing but by okay. So I think this is clear. So by looking at this, you can directly write the okay. Now you can put here, okay, you can put in this differential equation all these things whatever we have considered, right? So let me write here. So it is nothing but x4 dash, right, plus 2 x4 plus 4 by double dash is there now, so x3 plus 6x2 plus 8x1 equal to 5u. It's a very simple. So you can see what is x4 now. X4 dot is going to be minus 8x1, right, minus 6x2 minus 4x3 minus 2x4, okay, plus 5u, right? So you are writing just coefficient of this in the last row. You see minus 8 minus 6 minus 4 minus 2, right? So I have told you the by inspection technique. You can also do like this. You just assume y equal to x1, then keep on differentiate the state vector x1, right? So you will get by dot that you consider x2 and so on. Keep going, right? You will get it. Yeah. So this is the detailed procedure that I have told you, right? Okay. अब यहाँ से आप you can see, so you can make the like this. So x1, x2, x3, x4, and put the coefficient here. In case of x1, you see, in case of x1 may only one coefficient is there, that is x. X2 has only one coefficient, so x1 is not present, so it is 0. It is 1, other is 0. Now it is 0, it is 0, it is present, so it is 0, right? And last one is minus 8, okay? Minus 6, minus 4, and minus 2, right? This is A matrix. You can write x1, x2, x3, x4, right? You're writing ax simply, right? From the given equation, okay, from the given equation you can say you're writing a times x, okay? So A matrix कैसे करेंगे? This is a coefficient matrix only, right? Coefficient matrix of each equation. So this is, you can say, the first equation that you have got, the second equation, the third equation, and this is the fourth equation. Okay, so from these three equations you can get, and then this, from this equation you can get okay, and this equation will give you output, right? Because there is only x1, so you can say that your y is going to be x1, and now this will be b. B is what you see here. Only in case of x4 this guy is present 5. You can say that this is 5 and all guys are 0. So this is u. Now see y कैसे find करेंगे? Y is nothing but 1 0 0, and here x1, x2, x3, x4, and because since only x1 by equal to x1 now, so if you try to solve this you will get by equal to x1, right? So whatever equations are there, accordingly we collect the coefficient, right? Okay, so ये एक model है, that model you have to remember, right? And the second model that I'm going to talk about is state model to transfer function. देखो differential equation given है, it's a very easy way of finding at least two forms, canonical controllable canonical form as well as the observable canonical form, OCF, right? That is the first model that you can obtain from state space. Second model that you can obtain, okay, the second kind of problem, type of question that you can expect, okay, finding or determining state model to the transfer function, right? So you will be given a transfer function, okay, you will be given a transfer function and you have to find the state model, simple, right? You will be given a state transfer function and you have to find the state model, right? Please remember, it's a very easy process. Okay. Okay, so if you are able to do like this quickly, you can solve it. Okay, it's a very simple process, please remember. Hmm. So how to get this state model? State model is nothing but what? X dot equal to ax plus bu. There are many students who doesn't know what is state model, right? Okay. Suppose transfer function is given and they are asking what is state model, but in the exam they might ask this, or they might ask what is state transfer matrix, so on and so forth. What is B matrix? What is C matrix? Right? So this is nothing but this, and by is going to be Cx plus du. So almost in all the cases this d is 0, right? Whatever cases, whatever equations we have considered till now. Suppose we have got transfer function, right? Okay, so let me solve the example here, right? Write the state model. Write the state model. Okay, to the given transfer function. So I'm going to tell you again the by inspection technique. Okay, remember the by inspection technique is one of the powerful techniques. You can quickly eliminate the options and you can get the answer, because solving control system should not take much time, right? If it is not highly numerical, if options are given and you have to just find this. Okay, so you can directly find it. Okay, suppose we have got transfer function here by s upon input is u of s. Okay, in case of this state model, here the output is by and the input is u, right? So it is given 2s plus 3 upon s square plus 5s plus 6. Okay, you see how quickly we can write this. What is the order of this characteristic equation? You can see the maximum order, I mean the degree here, you see 2. Okay, you can say the so number of state variable is going to be 2 also. So you can say x1 dot x2 dot, right? Understood? And now you can fill this guy, right? So how to fill this guy? You have to remember CCF, right? So CCF is nothing but 0 1. You have to write like this, and last row you fill. You just go like this. Okay, you go like this. Okay, from last to first. From last to first you have to go. What is last to first? That is you can say and take the opposite sign. So you take -6 here and you take -5 here. This is a matrix that we have got. Okay, plus. Now you have to write for B, right? So B is going to be what? That is very important to remember. Okay, so what you can do here is simple. It's very simple, right? Okay, so the B matrix you can obtain like this. Okay, you don't have to see here, nothing is common, right? In this case, from the numerator you see nothing is common. Yes, nothing is common, you can say, right? You can't take. So if nothing is common, then this B matrix will be starting from here 1 0 and this is U. If something is common, then you can write here, right? That is important. Now what is the by matrix, right? So by matrix, this is I'm writing for canonical form only. So by is going to be what? Okay, y is going to be what? Tell me. So as it is, you have to take value. Okay, you go from here, right, like this. Okay, from small from this to this. Okay, like here s to the power 0, s to the power 1, and write like this 3 2. So getting state model from transfer function is also very simple, right? Getting state model from the transfer function is very simple. Okay, it's an important case that you have to understand. Okay, I hope this makes sense to all. Fine. So I will take one more question to explain you quickly, right? मान लो एक क्वेश्चन है, एग्जांपल नंबर 2 we can take. मान लो आपके पास दिया है bias by US, right? Now it is given as 2s cube plus 4s square plus 6 upon s to the power 5 plus 3s to the power 4 plus 5s square plus 7s square plus 9s plus 10. देखो इससे how to find A matrix, right? So you can get the A matrix. A matrix means there are 5 poles, you can say, right? Okay, maximum is 5 here. So 5 by 5 matrix you might get. Okay, 5 by 5 matrix, please remember, right? 5 by 5 matrix. Okay, okay. So order of the matrix you have to find, order of the matrix. Okay, so number of state vector कितने होंगे, that you have to decide. Okay, so it is s to the power 5, you can say. So this is, yeah. Now start with 0 1 0 0 0, 0 0 1 0 0. So you have to write this till 4 rows. Now 0 0 0 1, right? So this is nothing but identity matrix only that you have got. The last row will be the last row going to be what? Last row start like this, okay, and take the opposite sign. So it is obviously minus 10, minus 9, minus 7, minus 5, minus 3. Okay. So A matrix you got. If you want to write in OCF form, take the transpose of that. Now, what is B matrix? Okay, B matrix का मतलब क्या है? You see here, guys. You see here what is the common, okay, from the numerator. If you see something is common here, so common you can take it 2. Okay. If you are able to take something common, so right here, rest all will be 0. Rest all is gonna be 0. Please remember, this is B matrix. This is how we get B matrix. Okay. If something is common, right, that you can say K is common from the numerator, that you have to write in the P matrix. And what is C matrix? So C matrix, I have told you, you have to go like this, right? Okay, you have to go like this, right, with the same sign that you have to write like this. Okay? So यहाँ पर कितना जाएगा? You can say that. Fine. But in this case, you don't have to. Okay, you have to go like this from here, because this is K, you can say, already taken out, right? So you write these coefficient. Okay, so you start with D, right? Next should be S, because one S term is missing, so you can say 0, then 2, then 1, right? Okay, I hope this makes sense, right? And one term is not present, so you can say 0. So this is C. Right? So please remember, what is the point of caution? For B matrix, you have to take something common. That common thing you just forget now. For C matrix, whatever common you have taken, don't multiply inside, and then write like this. Okay, so it is very simple. Okay? You go like this, but write like this. You go like this, but write like this with opposite sign. Okay? So this is CCF. Okay, so I'll take more concept in the part 2 session, right? So this is part 1, you can say. Thank you so much. Please let me know if you are able to write, if you're able to find the state model from differential equation and from the transfer function, right? Next concept will be, diagonalization, okay, or normal form, or Jordan, okay, and so on and so forth, right? And then we will talk about state model from the signal flow graph. Okay, these are very important things. At the end of the day, 2 important concepts is there. One is controllability, one is observability, right? So if you want to check controllability or observability, you need a matrix that is called state transition matrix. So we will see that in detail. Okay, and suppose state transition matrix is given, how do we obtain the transfer function? That is also one of the very important concepts. So I'll tell, okay, vice versa, everything. So in this chapter, these are the things that you have to learn. So smart method you learn. Okay, I hope you might have enjoyed. Thank you. Take care.